Hey, this is John here, back with tutorial number 4. This one here is on the Makefile system for the ei-freertos repository. Now that you've set up the repo, you've had a look at what everything does, you've seen how the application runs, I suppose the next logical step is how's the application actually built? We have all of these files and all of these folders that we've laid out in a way that kind of makes sense, hopefully, and now, so how does all that get actually put together? How does it all get compiled and then put into one binary that then you put onto your chip? Where are all these Makefile rules? Like, what do I type? So this video is going to kind of go over a lot of the tutorials, a lot of the Makefiles that and the Makefile chain, I guess, that gets called when your applications get built, to hopefully, I don't know, give you a little bit more of vision and insight into what exactly is going on. So let's start off. If we go down here and go back to our root repo, if I type make, it's no Makefile found. It doesn't know what to do. That's because all the Makefiles for all of our applications are actually stored in the application folders themselves. So if I go into apps, low power, and then I type make, nice, found a Makefile. It can start running and doing things. That's the way we've set everything up in this repo. Each application you'll see here has, has a Makefile, and that's where the starting Makefile for the whole build chain lives. So you have to call make, whether it's make all, make clean, make debug, whichever rule you want to run. You have to run that specific rule from inside the application folder. So you'll see here what this looks like in low power. If I open up unified bases, you'll see this is unified bases. It looks pretty much identical. So you can see here it defines the project name, it defines the platforms that build for that specific application, a couple other things, and then it calls mcommon. As you'd expect, the application Makefile defines application constants, right? Kind of makes sense. And then it calls mcommon. Now, all other Makefiles are going to call mcommon. That's because mcommon is the next chain of the Makefile, and then it is going to call everything else and continue building the file. So after this one, we go to mcommon. So let's go have a look at what that looks like. So mcommon. Now this is the next file in the Makefile chain, I guess. So this just defines some stuff depending on if we're in verbose mode or not. This you'll notice here when I type make, to actually make something, I have to give it a target and say like it equals the bleed tag or the argon or something. This kind of handles a little bit of that. It also excludes certain rules from needing that. So if I type make clean all, it doesn't need to have a target, because if I want to clean everything, like shouldn't need to specify a target for it to just clean every target. And things like that. We also, this here checks to make sure that there's only one J-Link device attached to your computer, because if there's two, there's kind of an ambiguity in which one we should actually be programming. Yeah, and so all of this, you shouldn't generally have to look at it. Now, if we go to the bottom, there's 6 different includes. The way these include things work, by the way, in case you're not familiar, is basically, it works the same as the C preprocessor hash include. It just gets that Makefile and it just kind of tacks it onto the bottom of this file and continues reading. It's not a special keyword that does something different. So we'll see here, we start including other Makefiles. So I guess let's start at the top and just keep going down until we figure out everything that happens. So next thing we include is M directories. So M directories. You'll see this here. We're just kind of defining a bunch of variables. This one's a nice simple one to look at and go through. You'll see the app, we're defining appsdir as the repo root / apps. Apps test directory is repo root / apps test. Basically all this lets us do is in our code, if I want to refer to the object directory, I just type object directory instead of build directory target object project name. So it's just cutting down the variables that we have to write in further Makefiles. So really we're just defining basically a bunch of names here, and that's pretty much it. So the next thing on our list is, now things start to get a bit more complicated. We're calling core-dir /platform/target/make_target. So the target variable, that's actually the variable that you put in down here when you ask to make an application. So make target equals, like make all target equals argon is going to sub in argon as both of these variables. So what this includes is actually the Coursera directory. So this is Coursera here. And then it goes platform, that's platform, and then it is argon, so argon, and then m_argon. Hey, so you see that file exists, and this is just another Makefile. So if we look at this Makefile here, you'll see that we're defining the platform CPU to be the NRF52840, and then we're actually just including something else. So we're actually including something from Coursera architecture, NRF52 CPU, this specific CPU, and then this Makefile here. So you can see that now we're including a specific Makefile for the specific type of NRF chip that we're compiling with. If we look through this, basically we're passing the compiler arguments like, hey look, we're little endian, we're using ARM thumb instruction set instructions, I guess. So M CPU equals the Cortex M4, and we're passing in a whole bunch of specific variables for the CPU that we're using. Also down here we handle the soft device for the specific CPU we're using, which handles all of the Bluetooth and things like that. So you can see that chain, I guess. This line here, it is including the target, which is the board, I guess, that you're building for, so that's the argon. But then the argon itself, it uses a specific platform CPU. So then that includes the platform CPU, which includes the variant of the CPU and all of that stuff. So now if we go include, now what it includes is this specific CPU architecture Makefile. So if we remember, we go back to the argon, I suppose. Platform CPU is this, and then this defines the CPU architecture to be NRF52. So if we go back to M common, what this is doing is including m_nrf52.make. So if I just search for that, m_nrf52 make, sweet, found it. So what this does now is this is a Makefile for all Nordic Semiconductor NRF52 chips. So we can build for the NRF52840 or the NRF52832, which are two different chips and they have different capabilities. They're very similar though. So both of them use this Makefile because they're both from the NRF52 family. So I guess all this waffle was getting down to is there's kind of a number of different layers that all need to give information to each other. We make an application for a board, then that board uses a specific CPU, right? It might use the NRF52840. That belongs to the NRF52 chipset and is the NRF52840 variant. So there's a Makefile for each one of these. Because the NRF52 chipset, this folder here is going to handle the including of all of the HAL files because both of the variants use the same HAL files. Except this file here for this variant is going to handle things that are variant specific, like the soft device, right? So I hope that kind of makes a little bit of sense. We're just including all of the files and folders for that specific variant that we are compiling for the platform. I hope that kind of makes sense. So if we look here now, this is where we kind of get into the brunt of it. We're defining the ARM90 ABI as our compiler for the NRF52, and these are all of our toolchain tools. If we kind of go down here, this is where we include pretty much the entire NRF52 SDK. You'll see there's the NRF libraries, NRF modules, NRF libraries, so all of this comes from the NRF SDK. Yeah, if we keep going down, yeah, basically that's it, and it doesn't include any other files. So something to probably note, now that we've covered these two guys, which both of these lines here, they include all of the platform-specific code. What's worth mentioning is that unless you're adding another platform to this repo, or unless you find some crazy deep bug with our code, or maybe there's an update from Nordic Semiconductor for the HAL because they've added errata or something like that, you never have to touch this stuff. Don't worry, we've already handled it. I'm just kind of showing you that it's there and how everything gets built. You aren't going to have to touch this at all, so don't worry about that. So with that being said, I guess let's continue. Now, I believe this dash here in front of this include basically says, hey, if there's errors, don't even tell me about it. It just says run anyway. So we're including Coursera /MRestricted, and that's Coursera. Coursera is actually this directory that I'm in here, and there is no MRestricted. And that's why the dash is here, because right now this would be erroring, saying there's no MRestricted file, and we aren't getting errors when we compile things because this little dash is there. So what MRestricted is for is, let's say we want to give we want to give an external company access to this code, but then also give them access to a small amount of our IP, like Cyra's IP, stuff that isn't included in this repository. They put that IP in the MRestricted folder, and they can include the stuff, they can include our IP into this repo. So right now, this open source repo doesn't have one, because we aren't releasing any IP with the open source repo that we don't want to give away, obviously, because then it would be open source and not restricted, like this file says. So that's what this line does. Basically, don't worry about it unless we give you extra code that you're supposed to add in. Alright, and that leaves two last Makefiles that get attached after this. So let's have a look at these. There's M sources, so we go M sources, and what this does is this pretty much adds in, this pretty much includes all the core Cyra folders, I guess, to make sure that everything that we've added in gets compiled. So if we look down, basically see we're saying core Cyra sources plus equals like everything in the architecture Bluetooth folder, everything in the interface folder. And if we look down, basically what it's doing is from here up is kind of adding in all of those files, and from here down is adding in C flags for compiling. It's adding in warnings. It's, yeah, just basically like this here does colors, just flags for the compiling process, I guess. So, and that leaves M rules down here. Now, if I go to M rules, you'll see this Makefile here is like 400 lines long. It's a big one. So M rules, as the name would suggest, contains all of the Makefile rules that we use in the repository. So it defines what things like make flash does, and make flash debug, and make clean, and make tests, and yeah, everything. So this file's without a doubt the most complicated of the lot of them. And this code here is probably the complicated part of it. So these here are all specific rules, so compile rules. What this does is it turns like arbitrary C files into arbitrary object files. So we kind of clump our code base up into like a number of libraries, and we compile them all, and we spit out some static library once we're finished with it. Then once we get our application, we link it with all of the functions and all of the static libraries that we've created. So this just handles all the creating of that. And again, you should not have to touch any of it. It's all already set up so it works. Yeah, I'm just running you through how it works, I guess, and where to look for the different parts. So now we're getting into the rules. So if you type make VS Code, or make TDF, or make stack, or make size, this is where all of those specific rules are detailed. Yeah, so this is how we make ELF files, and how we make hex files, and yeah, how make clean is, and every rule is in this file. So if you're ever curious about what exactly is happening when you type make flash debug or something like that, you'll be able to find it in this file. So if I go flash debug, nice. This here is specifically exactly what's happening when you're typing make flash debug. Yeah, so if we go back to make common, make rules is the last one. And so basically, once you hit this, your make command has everything. It finds the rule that you want to run in this file, and it runs it. And that is how your application's made. So I know I didn't go into the nitty-gritty details of exactly how the application gets built and what gets compiled with what and things like that. If you really want the details and to delve into it that deep, you can go through these files yourself and figure it out. But for the level I want to go into for this video, I'm just kind of showing you how roughly things get made and what Makefiles feed into what and why. Then this video hopefully is good enough. So look, I hope this video has kind of given you a bit more of an understanding about how our Makefile chain goes through, like, when you type make to actually compile our program, and maybe if you want to add things or have a fiddle, you'll know where to look. Cheers.